Okay, so for this one, we have to find VO. Hold on, let me make this larger. Sorry, give me a sec. There we go. Okay, so we have to find VO here. We're given the voltage formula. Uh, so let's see how we can start. So let's get the impedance for all our values. So the impedance for the resistor will just be 10 ohms. The impedance for our inductor will be imaginary number times the radiant velocity or angular velocity times the inductance value. The angular velocity is 10 and the inductance value is 0.5. So it'll just be 10 times 0.5, which is just 5, so J5. Alright, now for the next part, the capacitor, it'll be 1 over JWC. So that'll be J10 1 over 20, and that gives you 0.5. Then 1 over 0.5, that's just 2 over J. And then you can bring the J to the top by doing the following, or just like this, there. Timesing the top and bottom by J will give you minus J2. So we finally found all our impedance values. So this is minus 2J, and then this is just 5J. Now these two impedance values, they're in parallel, so we can combine them up. So 1 over 10 plus 1 over 5J to the power of minus 1. What is that equal to? So put your calculator in imaginary mode, and you should get the following. 2 plus 4J. Okay? So we can rewrite this circuit like the following. 2 plus 4J. And then we have our capacitor, which has an impedance value of 2J. Alright? Now we have to find VO, which is the voltage between the capacitor. So first, let's focus on our voltage source. So we have 20 cos 10t plus 100. Let me turn this into phasor domain. So it'll be 20 phasor 100. Then let me get the imaginary and real parts. So it'll be 20 cos 100 plus j 20 sine 100. So 20 cos 100, that's minus 3.473 plus 20 sine 100, that's 19.691J. Okay, so we're gonna have our voltage source be represented by this. So to find VO, we can do some impedance division. So we're trying to look for the voltage source at this region. So let's do minus 2J all over 2 plus 4J plus minus 2J. Okay, so we're trying to look for the voltage at the minus 2J impedance region, this part. So we'll put that up here as these two are in series. And then we times it by our source, which was minus 3.473 plus 19.691. Okay, so I pretty much I did some voltage division here. You could do a mesh instead. That's also perfectly allowed. So let's putting all of these values into my calculator. Let me see what I get. So just give me a quick second. Okay, so for the real part, I get 11.582, and then for the imaginary part, I get minus 8.109 J. Now let me get the magnitude of this. And let me see what I get from that. So I get 14.138. Okay, I'm going to use this to find the phasor. And then to find the degree, I just do tan. The imaginary part goes on the top, all over the real part. And so my theta will be okay, so it's minus 35 degrees. So the formula for VOT will be 14.138 cos WT, and W was 10, so 10T minus 35, and this is in volts. And that's your final answer.